Okay, we're going to look at number 13 in section 6.3. We're going to find the volume of the solid obtained by rotating the region enclosed by the graphs that are given about the line x equal negative 38. Okay, so notice x equal negative 38. That is a vertical line, right? X equal constant is a vertical line. Y equal constant is a horizontal line. It's trapped between these two curves, so I found the point of intersection over here by equating the y values, right? When does x equal 2 times the square root of x? So if I square both sides, I get x squared equals 4x, subtract 4x, factor out an x, I can see x is either 0 or 4. And we can see that here is the graph of y equal 2 times the square root of x. Right? It's just a vertical stretch, if you will, of the square root of x function. So at 1, it's equal to 2. By the time we get to 4, it's equal to 4, since the square root of 4 is 2, and 2 times 2 is 4. And then this is the line y equal x. Okay. Now, way out here then, probably not to scale, but way out here, probably further out here, is x equal negative 38, this vertical line. So we're going to take this shaded in region bounded between these two curves, right? That's the region we're talking about. We're going to rotate that about this line. So it's going to come out of the page, way out, go back down into the page, way over here somewhere, and come back around. And we're going to get this interesting looking three-dimensional solid. So what's the volume of that solid? Well, we're going to use the washer method, it turns out, in this case, and we're going to have to integrate with respect to y to do that, right? So notice we're integrating from y equals 0 to 4 because this point of intersection, of course, x is equal to 4, but of course, when x is 4, we know that y is also 4. And so we're integrating from 0 to 4 along the y-axis. And so here's an arbitrary interval where we have a rectangle here. Notice it's horizontal. And we're going to rotate that about this dashed line, and we're going to get this washer, right? So not to scale, but here it is. Here's this washer. And the right here in the center is the axis of rotation, x equal negative 38. And we're looking at the inner radius little r and the outer radius big R. And so the area of the shaded ring that we have here is pi times the big radius squared minus pi times little radius squared. So what are the values of little r and big R? Well, little r will be the distance from our axis of rotation all the way to the bottom right here, or no, bottom, the left side, if you will, of our um, rectangle. Right? That's forming the inner edge of this washer as we rotate it around. So what is this distance all the way from here to here? Well, the x coordinate here is equal to what? Well, if y is equal to 2 square root of x, let's note that I can solve for x by squaring both sides and then multiplying by 1/4. X is 1/4 y squared, right? So x is equal to 1/4 whatever y squared is, right? That's this x coordinate on this curve. And then what's the x coordinate here? Negative 38. So the distance will be the difference of those x coordinates, right? So it's going to be x is what? 1/4 y squared minus what? A negative 38. And if you do minus a negative 38, you get plus 38. So down here, here is your inner radius. And notice that will work because the inner radius when y is 0 is just 38, right? There's 38 units from here to here. And as we move up, right, that distance gets longer and longer until by the time we get to y equal 4, right? Notice over here, this is 4 units here, plus 38. We should be what? 38 plus 4 should be 42. And this formula does that. When y is 0, obviously this is just 38. And then when y is 4, I get 16. 4 squared is 16. 1/4 of 16 is 4. 4 plus 38 is 42, as it should be. So that gives us the inner radius. The outer radius will be all the way from this axis of rotation to this curve, the linear function, right, to the right side of our rectangle. So what's the distance from this line all the way to here? Well, what is the x coordinate here? Well, since y is equal to x, we have x is equal to y. So the x coordinate is just equal to y. And then here, the x coordinate is, of course, negative 38 always. So the distance will be y minus a negative 38, or y plus 38. So this is strange result. Again, you might have a slightly different number than x equal negative 38, but it probably is, the setup is still basically the same. Now the integration is a little bit algebraic intense here. So I've got the integrating this area, right, from 0 to 4. Excuse me. Factor out the pi from both of these, leaving capital R squared minus little r squared. So capital R squared is this, little r squared is this, and we're going to integrate. So a lot of work. We have to expand this out. Use your calculator if you have to to deal with the big number there. Same thing here. Squaring this out gives us this. So just make sure you understand where that came from. And then I combine like terms. So I've got negative 1/16 y to the fourth. I've got a y squared minus 19y squared. That's negative 18y squared. I've got a 76y. And notice the constant's 1,444 minus that just goes away, goes to 0. So this is our simplified function we're integrating that gives the area of these, these washers. Okay. And now it's just a matter of using the fundamental theorem of calculus part 1. We find the antiderivative of each of these. Hopefully this makes sense. We plug in at 4 and we plug in at 0. Of course, if I plug in 0, I get 0 in this case. So here's the values plugged in at 4. And then finally, when you add that all up, we get the final exact value of the volume of this solid. Okay, rather interesting problem. And hopefully this makes sense. If not, please let me know.